Welcome to yet another episode where we shall be looking at the proposed memorandum for the Technology Grade 8 end of year examination, okay? So this paper is out of 80 marks. The duration was 1.5 hours, okay? So we have 40 marks for the knowledge, and then we have 24 marks for the design skills, and then the values and attitudes are going to carry 16 marks. Okay, so let's see what we have to do. 10 minutes reading time. Okay, read all instructions, answer all questions, use a pencil ruler for drawings. Scale is 1:1. If it's not stated, then there is a case study. And then for that, all those sections. Okay. Now, with question number 1, section A, circle the alphabet of the right answer from the given options. Okay. 1.1, a term that is used to describe a material that conducts electrical current is, we know that this has to be a conductor. Ne? So conductor is the correct answer for 1.1. And then 1.2, cells connected in series in a circuit where the resistance stays the same. What do they produce? Okay, do they produce more resistance? Do they produce more current? Do they produce more current and voltage? Or do they produce more parallel circuit? So D is out. I mean, we're talking of cells connected in series, okay? So one thing we know is that if we have the cells that are connected in series, the current that is flowing through these cells is technically the same current, okay? So does the resistance increase? I'm going to ignore this. I did mean that we're talking of valves that are connected in series. Yes, the resistance was going to increase, okay? But in this case, we're talking about cells. Okay, does the current increase? Yes, the current is going to be more, okay? But also the voltage will increase. So I'm going for option C as my answer. 1.3, gears can also change the direction of motion. Very true. In an egg beater, the crank turns the driving gear, which in turn makes the beaters rotate. The transfer of motion is called. So in an egg beater, how is the rotation moving? So it's from the rotary motion, okay, into what we call the linear motion. So vertical to horizontal, horizontal to vertical, linear to rotational, rotational to linear. Okay, then 1.4, the function of a cell is, what does a cell do? We know that a cell is basically a source of energy, okay? It stores energy. Truth table, connector, energy transfer is an energy source. And then a material that can rot is also known as biodegradable. So option A becomes the best option then. Okay. Then question 2, match A and B, these columns, okay? So column B, we have a gear train, bevel gears, rack and pinion, worm gears, spur gears, and then we have the pulley. Okay, so 2.1, wheels that mesh with each other, they change the speed and the direction of the rotating shaft. So these are gears. Okay, so what do we call those types of gears? No. Wheels that mesh with each other that change the speed and the direction of the rotating shaft. Now these have to be spy gears. Okay, so E will be the perfect answer, the spy gears. Okay, normally they are of the same size or slightly different size, and then the rotation is just the same. Okay, 2.2, these gears work on a screw principle. Okay, the rotation of the screw wheel causes a much slower rotation on the toothed wheel. The input and the output shafts are also at 90 degrees. So chances are high that this is the worm gear. Okay, so D will be the best answer. And then 2.3, gear wheel and the toothed bar to change rotary into linear. So this has to be the rack and pinion. Okay, the rack and pinion. And then 2.4, these gears change the direction of rotation through 90. The teeth are angled at 40. So the gears fit together at right angles. This must be the bevel gears. The bevel gears. And then 2.5, two or more spur gears meshed together are called a gear train. Okay, when we have two or more spur gears, then we have what we call a gear train. So the aim is just to create just one direction of the gears. Okay, then question 3, truth or dare, or truth and false. State whether the following statement or statements is true for T and then false F. Number 1, the main function of an idler is to change the direction of rotation of the output gear. That is very true. Very, very, very true. Create similar motion. And then the SI unit for resistance is ohm. Very true. Levers with a mechanical advantage that is greater than 1 helps to make work easier. This is also true. For as long as mechanical advantage is greater than 1, then work becomes very light. In a third-class lever, or in third-class levers, the load is always between the fulcrum and the effort. The load, no. It is the effort that is between the fulcrum and the load. So this is a false statement. Okay, and then 3.5, switch controls, or the switch controls the flow of electric current. This is very true. Okay, so it falls under the control components. Question number 4, complete the table below by writing the name of the component, draw the symbol, and indicate whether the component is an input, control, or output device. Okay, so this looks like a motor. Okay, it looks like a motor. The symbol for the motor is just connecting wires with M in between, okay? More like a Motorola. And then this is basically a control, okay? We know that this is a light bulb or it's a lamp. Some people will call it a lamp. And the symbol, we can have something like that with some connecting wires, or some people would prefer to put something like that. Okay, so those are the symbols that are acceptable. And then we know that a bulb is an output, but it can also be used as a control, like in the case of the LEDs, okay, whereby they indicate to us whether current is flowing or something of the sort. And the next, this is like a switch. It looks like a switch. And with a switch, you either draw the closed one, but I prefer to draw the open one, okay? And the switch, we said, falls under the control. This is a cell, okay? Don't call it a battery. It's a cell since it's one. And the symbol for a cell is something like that. And then a cell is used for input, okay? And then lastly, this thing that is colorful is called a resistor. Okay, a resistor can be drawn just in this sort of manner, or some people have that variable resistor with a cross or with an arrow in between. So whichever one you draw, that is a resistor. Alternatively, some people prefer to use this. Okay, so resistor is also a control device. Controls or regulates the amount of flow. All right, so guys, that is section A with a total of 40 marks. Now section B, question number 5, state whether the following items represent the first, second, or third class lever, okay? A pair of scissors. So with the scissors, we know that the midpoint represents the fulcrum, okay? The load is going to be somewhere there, and then the effort must be here. So for as long as the fulcrum or the pivot is in the middle, that is a first class lever. Okay, and then 5.1.2, a wheelbarrow. So with the wheelbarrow, where do we find the load? We know that the effort is there, the load is in the middle, The fulcrum is at the end here. So for as long as the load is in the middle, that is a second class lever. And then next we have the stapler. So with the stapler, we're seeing that the fulcrum is at the end, okay? The load is going to be at the end also, and then the effort is going to be in the middle. So this becomes a third class lever. All right, then 5.2. 5.2, the following diagram represents a peg that operates in a lever mechanism, okay, especially those plastic ones. Okay, we have A, B, and C. At which letters are we going to have the following? Number one, the load. So the load, chances are high, is going to be at the end of A, okay? And then the effort, your hands must be this side by C, and then the fulcrum is the B. All right, then 5.3. If we have the load of 300 newtons, and the distance of the load from the fulcrum is 30 meters. Okay, so the load is 300. And then the load distance is 30. And then the effort is 60 meters away. So the effort distance is 60 meters. They want us to find what? The effort force. All right, so they gave us a formula that when you get the load arm times the load should be equivalent to the effort arm times the effort force. So substituting into the formula, the load arm is 30 multiplied by the load force, which is 300. It should be equivalent to the effort arm, which is 60, times the effort force. So we know that 3 times 300, that's going to give us 9,000 is equal to 60 EF. Then divide both sides by 60 over 16. Okay, so this 60 cancels that, 9,000 over 60, which means our effort force is 150 newtons, okay, which means there's mechanical advantage in this thing. Okay, then they want us to get the mechanical advantage using the formula load over the effort. So these are forces that we're talking of. So the load is 300 over the effort that we found to be 150. So we get a mechanical advantage of 2. Okay, then 5.5, read the case study below and answer the questions that follow. Connecting electricity illegally. Okay, so residents know that illegal electricity connections are very dangerous, but they have no alternative, okay? There's nothing we can do. It's cold and we have to boil water for cooking as well as bathing. Say the residents in Kwa Madakwa. Residents who do not have electricity connect illegally with people who have electricity. Another resident said that it has been like this for very many years. The situation is not about to change anytime soon, and we will continue connecting electricity illegally because of no one wants to give it to us legally. Okay. The municipal spokesperson said that they randomly check for illegal connections and disconnect any household that uses electricity illegally. They give them a fine, but the residents reconnect as soon as the municipality officials leave, even after paying the fine. Okay, so municipality loses quite a lot of money through these illegal connections, and he warned residents of the dangers of illegal electricity connections. Tampering with electricity cables is very dangerous, guys, and people can die doing this, he said. So that is the municipality spokesperson. So answer the following questions based on the above case study. So we need to discuss why people need electricity at their homes. So number one, we said for cooking, okay. And then we also use it for lighting. We can also use it for heating, okay, so that people can feel warm. And then some people have geysers, so we can say for bathing purposes. Okay, and then 5.5.2. How do residents who do not have electricity get connected to electricity if the municipality does not provide them? So we're saying that they connect it illegally. They connect it illegally with people that have it. With people that have it legally. Okay. And then 5.5.3 lists two alternative energy sources that residents can use to avoid using electricity illegally. So the first one, we can always use the paraffin, okay? And then two, we also have the most favorite, which is the gas. And then we could also use what we call the solar panel. Okay, there's also the coal. It's not only for braai, okay, but it could also be used as an alternative. And then 5.5.4, do you think it's justifiable for residents to illegally connect electricity? Support your answer. So this depends, but ethically, it's a no. Okay, it is a no. Why? Because the dangers are more than the benefits. So it can cause this, it can cause death. And then the other thing is that it's a disadvantage because some people will pay more, will pay more because of the illegal connections, because of the illegal connections. So you find that the people that are connected legally will end up paying more money, while these ones that are connecting illegally are not paying anything, okay? Top of that, we shall have a whole lot of load reductions, load shedding, transformers blowing up, and all those aspects. 5.5.5, these three safety precautions that residents must adhere to when using or working with electricity. So what must you bear in mind when you are using electricity? There's quite a lot of things that we need to look at. Number one, we need to keep electrical equipment away from water. Keep electrical equipment away from water. Okay, because water is the number one killer of these electrical equipment. And then two, you can install warning signs. Okay, we have people that are very stubborn, that even if they see that electricity is somewhere there, they will not care. Okay, so install warning signs. Now you also need to unplug. Okay, unplug the equipment safely. And then we could also look out for electrical lines. Okay, look out for electrical lines. That is if you're now traveling or moving. There are those that are very low, and then there are those that are underground. Okay, then you need to have what we call the child-proof outlets. Okay, small kids always love to put fingers almost everywhere. So you must have those outlets that tend to close as soon as you remove the plugs. And then you need to install properly and tidy. You need to tidy. Let's just say we need to tidy the electrical cords or the extensions. Okay, they shouldn't just be running around. In the process, they will break. Okay, so there's quite a lot of precautions that you need to really put into place. Somebody could also say familiarize yourself with the switchboard so that you know if there's an emergency, this is for the lights, this is for the stove, this is for all those, okay, breakers. Okay, question number 6. Consider the following parallel circuit below with two switches, okay, to control one bulb. Okay, so we have switch A and then switch B. Okay, so they're telling us that complete the truth table below using a tick if the bulb will turn on, and then X if the bulb remains off. Remember, in our truth tables, we normally use a 1 and a 0, but here they want us to use a tick and a cross. Okay, so switch off both A and B. Wait a minute, what are they saying? Switch off both A and B. So if A and B are off, no current is flowing, but according to this, okay, the bulb is connected here, but so it's a cross and a cross, okay? And then you switch on A, and switch off B. Switch on A and switch off B. So current will be flowing via this route. Okay, so it's going to light. The bulb lights. Okay. And then the bulb remains off. Nope. And then switch off A and switch on B. So it's just going to be the same thing. So this and that. And then switch on both A and B. Yes, the bulb is going to light up. But is the bulb going to remain off? Answer is a no. Wait a minute. Am I understanding the table or I'm mixing up things? Okay, so bulb lights up, bulb remains off. Oh, so meaning that the bulb lights up? No. Is the bulb gonna remain off? Yes. So that is a tick. Okay, I'm sorry for misinterpreting the question. So that is how it's going to be. Né? If you switch off both A and B, bulb lights up? No, there is no lighting up. The bulb remains off? Yes, that's correct. Switch on one of them, you're gonna get the light up. It remains off? No, it will continue lighting. Up, continue lighting, and so on and so forth. So that is how the truth table was supposed to be completed. Then 6.2, use the correct symbols to draw a neat circuit diagram for the circuits below. So we have two cells that are connected in series, two globes, which are basically the light bulbs with an open switch. So the two cells, we're gonna have to do something like that. Then the connecting wires, we can have our switch somewhere there, and then we can have the bulb. And then there we go for 4 marks. So probably 1, 2, 3, and then the entire circuit, which is 4. And then 6.2.2, we have cells that are connected in parallel, two bulbs in series with a closed switch. Okay, so now here they are showing us two switches. Mara, what's wrong with people? But let's follow the statement, okay? So if the cells are in parallel, we're gonna have it this way. Okay. And then we're gonna have the two bulbs that are in series. And then a closed switch. We can close it at this point. So just two dots to indicate the switch that is closed. Okay, two cells connected in parallel. So I believe this would be the best. Okay. Alternatively, someone can have it just like that. And then we have this sort of connection. Then you have your two bulbs. And then your closed switch. And then that. So that is just an alternative as long as we see the parallel combination. All right, guys. So that brings us to the end of this test, okay? I wish you guys all the best as you prepare, okay? And then let's meet again when we're looking at something else, okay? So if you found this helpful, please feel free to like, subscribe, and share the video, okay? Thank you very much. Bye-bye.